In the freezing, mud-slicked autumn of 1940, as the shadow of the swastika stretched across the European continent, the British Empire found itself backed into a corner. The miracle of Dunkirk had saved the men, but the fields of France were littered with the broken remains of their mechanized strength. Britain was an island under siege, its industrial heart being hammered nightly by the Luftwaffe and its supply lines being strangled by the U-boat wolf packs in the North Atlantic. In this atmosphere of existential dread, the British didn't look to science fiction or wonder weapons for their salvation. While Berlin's designers were already sketching out gargantuan tanks and jet-powered interceptors, a small group of engineers and planners in London were obsessing over something far more mundane, yet far more critical. They quietly deployed a system so simple it seemed almost unimpressive to the untrained eye. It wasn't a death ray, and it wasn't a code-breaking engine of brass and glass. It was a masterpiece of utilitarian logic, a system designed to solve one brutal, grinding problem that had plagued every army since the dawn of the industrial age: the problem of rapid, heavy-duty logistics in a world of total destruction. To the casual observer, it was just a piece of hardware, but to the architects of the British war effort, it was the silent enabler. It was a technology designed not for the glory of the parade ground, but for the filth of the front line. It was cheap to produce, easy to repair, and, most importantly, it worked when everything else failed. Britain didn't brag about it. They simply built thousands of them and waited. And across the English Channel, beneath the high-peaked caps of the Oberkommando der Wehrmacht, the Germans noticed. They saw British units performing logistical miracles in the North African desert and on the rain-swept coasts of the Mediterranean, miracles that should have been impossible for an army in retreat. The German military machine was built on a foundation of over-engineering. The Reich's designers, the men behind the Porsche and Henschel concerns, were obsessed with precision, complexity, and technical superiority. They believed that a machine's worth was measured by its tolerances and its sophistication. However, as the war dragged into its second year, this philosophy began to show its cracks. German tanks were marvels of engineering, but they were nightmares to maintain. A single broken component in a Tiger tank's transmission could require a specialized factory team to repair. In the mud of the Eastern Front and the grit of the Sahara, German technology was constantly being defeated not by the enemy, but by the environment. When German intelligence officers began to capture examples of the British system, they expected to find something they could scoff at. They expected primitive British craftsmanship. What they found instead terrified them. The British invention wasn't powerful in the traditional sense. It was resilient. Captured reports from the Abwehr and the engineering bureaus in Essen noted with growing alarm that the British system seemed nearly immune to the stresses of modern combat. It functioned perfectly in sub-zero temperatures that caused German lubricants to seize like stone. It continued to operate in waist-deep mud that swallowed German trucks whole. Even under the shock of sustained aerial bombardment, while German infrastructure shattered, this British system kept functioning. The realization was a psychological blow to the Reich. The German engineers understood that wars aren't won by the most advanced machine, they are won by the machine that is still running on the third week of the offensive. The British had discovered the secret of reliable simplicity, and that realization was more terrifying to Berlin than any secret Allied superweapon. It suggested that Britain had mastered a form of total war logistics that Germany simply couldn't match. By 1942, the frustration in Berlin had boiled over into a direct command from the highest levels of the Ministry of Armaments. Albert Speer, the architect of the Reich war economy, issued a decree that sent shockwaves through the prestigious design bureaus: recreate the British invention. It was a blow to the ego of the German engineering establishment. They weren't being asked to improve it, they were being told to duplicate it. Berlin demanded an exact mirror copy, every material, every dimension, and even the crude manufacturing shortcuts the British used to speed up production. German engineers, however, remained arrogant. They looked at the British designs and saw a lack of proper German craftsmanship. They were confident that if they applied their superior metallurgical techniques and their precise milling processes, they could build a version that wasn't just as good as the British original, but better. It is, after all, a simple design. It lacks the complexity of our own systems. We shall produce it in weeks, one Henschel engineer was reported to note in a memo. They believed that since they had mastered the complexities of the V-2 rocket and the Panther tank, this British trifle would be child's play. They expected a quick victory in the laboratory that would translate to a victory on the battlefield. It wasn't. The German teams quickly discovered that there is a profound difference between a machine that is simple and a machine that is refined. As they began to cast the first prototypes, they found that the British shortcuts they had mocked were in fact carefully calculated engineering trade-offs. The British hadn't built it crudely because they were incapable of precision. They had built it that way because that was the only way it would survive the reality of the war. The German copy began to fail, and it didn't just fail quietly, it failed in ways that baffled the most brilliant minds in the Reich. On the proving grounds of Kummersdorf, under the watchful, critical eyes of the Wehrmacht High Command, the first German-made prototypes of the British system were unveiled. To the naked eye, the Reich's engineers had triumphed. The German version was a work of art. It featured cleaner welds, superior-grade steel, and a finish that glistened in the cold morning light. It looked like a machine that belonged in a museum of industrial progress. On paper, every tolerance had been tightened and every efficiency had been maximized. But as the field tests began, the meticulous German perfection began to unravel with a speed that bordered on the humiliating. The tests were designed to simulate the grinding reality of the front: dust, heat, vibration, and neglect. Within hours, the reports coming back to the observation tent were a litany of catastrophe. The tightened tolerances, the very pride of the German design, became the system's Achilles heel. A handful of desert sand that the British original would have simply chewed up and spat out caused the German components to seize and jam. Parts that had been machined to razor-thin margins began to expand under the heat of friction, leading to catastrophic overheating. Where the British original had a looseness that allowed it to rattle and shake its way through weeks of constant use without much as a drop of oil, the German copy demanded a level of maintenance that was impossible in a combat zone. Maintenance crews, trained to the highest standards of the Reich, found themselves helpless. They couldn't keep the machines operational for more than a few hours before another critical failure brought the test to a grinding halt. The engineers stood in the mud of the proving grounds looking at their broken, beautiful machines, unable to fathom how the primitive British design could be outperforming the pinnacle of German science. No one understood why. They had copied the dimensions, but they had missed the soul of the machine. The failure at Kummersdorf wasn't caused by a lack of intelligence or a shortage of strategic resources like chrome or tungsten. It was the result of a fundamental, irreconcilable difference in engineering philosophy. British designers, many of whom had seen the chaotic, unscripted reality of the First World War, designed their equipment with a grim, empathetic realism. They assumed the worst of the conditions and the best of the men. They designed the system with the assumption that the soldier using it would be exhausted, caked in mud, shivering from cold, and under the deafening, bone-shaking stress of enemy fire. They knew that in the heat of a blitzkrieg, a soldier doesn't have the time to consult a manual or use a torque wrench. They built a system that was soldier-proof, rugged, forgiving, and brutally simple. German designers, conversely, were prisoners of their own discipline. They designed for a world that only existed on a parade ground or in a sterile laboratory. They assumed perfect conditions, a steady supply of specialized lubricants, and a soldier who followed a rigorous 50-step maintenance protocol with robotic precision. The British engineers respected the chaos of war. The German engineers tried to legislate it out of existence. When a British part bent slightly under pressure, it kept working. When a German part, hardened to a brittle perfection, encountered that same pressure, it shattered. The British had built a tool for a brawling, dirty war. The Germans had built a watch for an apocalypse. War, in its cruel and unpredictable nature, offered neither the time nor the environment that the German technology required to survive. In the Third Reich, the admission of failure was often interpreted as a lack of political will, or worse, sabotage. As the reports from the proving grounds reached the Ministry of Armaments, the reaction was not of correction, but of suppression. The sheer ego of the German engineering establishment refused to allow the truth to reach the Führer's desk. The disastrous test reports were quietly buried in classified archives, stamped with "for official eyes only," and moved to the back of the filing cabinets. Rather than admitting that the British system was fundamentally superior in its design philosophy, the order was given to push forward. Factories in the Ruhr Valley were commanded to keep producing the flawed copies, despite the frantic warnings from the engineers on the ground. The result was a logistical tragedy for the Wehrmacht. Frontline units that were already being bled white on the Eastern Front, began to receive crates of equipment they quickly learned not to trust. Stories began to filter back from the front lines of soldiers abandoning their brand-new German-made systems in favor of captured, battered British originals. A tool that fails in the middle of a firefight is worse than no tool at all. It is a liability that costs lives. Meanwhile, across the Channel and in the vast deserts of North Africa, the British forces continued to use the original system with devastating, quiet efficiency. It wasn't flashy, it didn't make the headlines of the newsreels, but it worked. It allowed the British to move faster, stay in the fight longer, and recover from setbacks with the speed that the German High Command simply could not replicate. The British invention remained the silent victor, a testament to the fact that in the brutal theater of World War, the most sophisticated design is the one that actually moves when the world is falling apart, and that made all the difference. In the final, desperate years of the war, the air over the Third Reich was thick with the scent of burning coal and the constant rhythmic thrum of Allied heavy bombers. The industrial landscape that had once promised a 1,000-year reign was now a patchwork of rubble and fire. In the underground bunkers of the Ministry of Armaments, a quiet, final meeting took place. The agenda was short, the status of the mirror copy program. The project was officially halted. It didn't end with a grand speech or a public admission of defeat. It ended with a red stamp on a stack of technical reports that had grown too thick to ignore. The German High Command hadn't stopped the project because the invention was physically impossible to build. They stopped it because they had reached a terrifying realization. To make the British system work with the same reliability as the original, they would have to abandon the entire German engineering mindset. They would have to stop obsessing over micron-level tolerances and start embracing slop. They would have to stop demanding specialized alloys and start designing for the scrap heap. For a design culture built on the legends of Krupp and Zeiss, this wasn't just a technical shift, it was a psychological impossibility. To build like the British was to admit that their own philosophy of technical supremacy was a lethal liability in a total war. With the Red Army closing in from the east and the Western Allies carving their way through Italy and France, there was simply no time left for a cultural revolution in German manufacturing. They chose to cling to their complexity until the very end, producing fewer and fewer machines that were more and more difficult to keep in the fight. When the guns finally fell silent across Europe in May 1945, the landscape was a graveyard of technology. Amidst the burned-out husks of Panther tanks and the twisted remains of jet-powered Wunderwaffen, Allied technical intelligence teams began the grim task of forensic analysis. They sat the British originals and the German copies side by side in the workshops of the Royal Engineers. The conclusion reached by these analysts was brutal, simple, and served as a post-mortem for the Reich's industrial strategy. Germany didn't lose the war because it lacked intelligence. Its scientists were among the most brilliant in the world. It didn't lose because it lacked the will to innovate. Germany lost because it overcomplicated a war that systematically punished complexity. While the Germans were designing a perfect mechanical watch to survive a mud fight, the British had designed a hammer. The British invention, the silent enabler, was never glamorous. You won't see it featured in the dramatic opening shots of war movies. It was never celebrated with medals or mentioned in the grand victory speeches of Winston Churchill. It was a humble, rugged piece of engineering that sat in the background of every major offensive, from El Alamein to the Rhine. But it worked. It worked when the soldiers were too tired to think. It worked when the mechanics were dead. It worked when the supply lines were broken and the world was screaming with the sound of artillery. In the final accounting of the Second World War, the British had mastered the one truth the German engineers could never accept, that in the chaos of the front line, the most advanced machine in the world is the one that still moves when you pull the lever. And that made all the difference.